Hey everyone, today we're going to be working on part 2 of lesson 1, solving equations with rational coefficients. Please make sure to have access to a notebook and pen or pencil or a whiteboard app so that you can follow along and work through the problems. So with our last lesson, we were just working on problems that had a rational number on one side of the equal sign, and today we'll be working on problems that have a rational number on both sides of the equal sign. So working through our first problem here, 1 1/2 s equals 16 1/2. We're being asked to solve and check our solution. The first thing we have to do is convert our mixed numbers to fractions. So to do that process, we take 2 times 1 and add the numerator. So 2 times the whole number, 2 times 1 is 2, plus 1 is 3, and we keep our same denominator. So 1 1/2 becomes 3 over 2. Same process for 16 1/2. 2 times 16 is 32, plus 1 is 33, and again, keeping 2 as the denominator. Then what we have to do, remember, we're multiplying our rational coefficient times its multiplicative inverse, which is the fraction inverted. These two values will cancel each other out. 2/3 times 3/2 is equal to 1. And then 2/3 times 33 over 2, we can do some factoring here. We can take 3 divided by 3 to get 1, and 33 divided by 3 to get 11. When we multiply straight across, we get 11 over 1, or just simply 11 for our final answer. Now to check our solution, all we would need to do is take our original equation, which is 1 1/2 s equals 16 1/2. We plug in our value 11 for s, then we have to convert 1 1/2 back into a fraction, so that becomes 3 over 2. When we multiply, we get 33 over 2. And when we convert the improper fraction 33 over 2 into a mixed number, 2 goes into 33 16 times, gives us 32, and 33 minus 32 is 1. So we do get 16 1/2 on the left-hand side of our equation, which means this equation balances out, so therefore 11 is an accurate solution for the problem. So I'd like you to try these on your own, which would mean stopping the video, try the problems, then come back and check your answers as I go through the solutions. So for problem D, we've got 4 1/6 equals 3 1/3 C. We have to convert both of these into improper fractions. So 4 times 6 is 24, plus 1 is 25 over 6. And 3 1/3 becomes 3 times 3 is 9, plus 1 is 10 over 3. Now we're going to multiply both sides of the equal sign by the multiplicative inverse of 10 over 3, which is 3 over 10. So I'm going to write that next to my value on the left-hand side. So 3/10 times 25 over 6 equals 3/10 times 10 over 3c. I like to put my fractions right next to each other. It's just much easier to compare and work with the values. So on the right-hand side, those two cancel out. I can do some factoring here. I can factor a 3 out of 3 to get 1, and 6 divided by 3 is 2. I can factor a 5 out of 10 and 25, so 10 divided by 5 is 2. 25 divided by 5 is 5. When I multiply straight across, I get 5 over 4 is equal to C. And then when I convert this back into a mixed number, 4 goes into 4 one time with 1 left over, and then I keep my denominator as 4. And I can switch it around to read C is equal to 1 1/4. Okay, for problem E, we've got -9 5/8. W equals 108. So we got some larger values here. We're going to convert this mixed number to an improper fraction. So 8 times 9 is 72. 72 plus 5 is 77. So we get negative 77 over 8, W, equals 108. Now we're going to multiply both sides of the equal sign by the multiplicative inverse of negative 77 over 8, which is negative 8 over 77. Don't forget the negative sign. This side cancels. And I'm left with W equals 108 times negative 8 over 77. Now this is a really large value, so you want to use your calculator here. And 108 times negative 8 is negative 864 over 77. And now I have to convert this to a mixed number. And by dividing, I know that 77 goes into 864 11 times. And 11 times 7 is 847, so I can take 864 minus 847 to get 17, which is my new numerator. So this becomes 11 and 17 over 77. And I have to make it a negative because I've got a negative sign here. So the improper fraction, negative 864 over 77, becomes negative 11 and 17 over 77 for your final answer. And our last problem, F, is 1 and 7/8 y equals 4.5. So again, we're changing these mixed numbers to improper fractions. 8 times 1 is 8, plus 7 is 15 over 8y. And then 4.5 becomes 2 times 4 is 8, plus 1 is 9 over 2. We're going to multiply by the multiplicative inverse, which is 8 over 15. The left side cancels, and I'm left with y is equal to, I can factor a 2 out of the 2 to give me 1. 8 divided by 2 is 4. I can factor a 3 out of the 9 to give me 3, and 15 divided by 3 is 5. So I multiply straight across. I get 12 over 5. And then when I convert this to a mixed number, 5 goes into 12 2 times, with 2 left over, and my denominator is 5. So my final answer is y is equal to 2 and 2/5. Okay, next we're going to look at solving equations with decimal coefficients. In the equation, 3.15 equals 0.45n. The coefficient of n is a decimal. So the coefficient is 0.45. Remember, that's the value in front of the variable. To solve an equation with a decimal coefficient, divide each side of the equation by the coefficient. So you'll find this is much easier than working with the fractions because basically it's just like solving a normal equation. Here we have 3.15 equals 0.45n. All we have to do is divide both sides of the equal sign by the coefficient of n, which in this case is 0.45. So we've got 0.45n divided by 0.45 and 3.15 divided by 0.45. The right-hand side cancels, and we're left with 3.15 divided by 0.45 is equal to 7. So n is equal to 7. Now to check our answer, we can just plug in 7 for n. And when we multiply 0.45 times 7, we do get 3.15. So this sentence is true and this equation balances out. So again, for practice, I'd like you to try these 3 problems. And I would recommend having your calculator handy to help you work with the decimals. Okay, so for our first problem, problem G, we've got 4.9 is equal to 0.7t. And remember, I said all you have to do is divide by the coefficient of t, which in this case is 0.7. The right-hand side cancels. 4.9 divided by 0.7 is 7, so we get 7 is equal to t. Or we can flip it around and say t is equal to 7. If I wanted to check this problem, I could just write the original equation, 4.9 is equal to 0.7 t, and then plug in 7 for t. So 4.9 equals 0.7 times 7. And when I multiply these two values, I do get 4.9. So 4.9 is equal to 4.9, and therefore this solution is correct, and the equation balances out. For the second problem, H, got negative 1.4 m is equal to 2.1. And again, it's just the process of dividing by the coefficient of m. Coefficient is negative 1.4. I divide by the same value on both sides. Left-hand side cancels out. And 2.1 divided by 1.4 is 1.5. So my final answer is 1.5. And then finally for problem I, I've got negative 5.6k is equal to negative 12.88. Dividing both sides by negative 5.6. And I get k is equal to positive 2.3. We've got a negative divided by a negative, so that would give us a positive answer. So k is equal to 2.3 is the final answer. So for our final example here, we just have an example of an equation being utilized to solve a word problem. Latoya softball team won 75% or 18 of its games. Define a variable, then write and solve an equation to determine the number of games the team played. Latoya softball team won 18 games, which was 75% of the games played. We're going to let n represent the number of games played. Write and solve the equation. So we know that they won 18 games, and that was 75% of the games played. So we're going to put a variable in, n, and try to figure out how many games were played total. So you can think of it as we're trying to find 75% of an unknown number of games. And to do that, we set up the equation 0.75n is equal to 18. And then we just go through our same solution process. We're dividing by the coefficient of n, which is 0.75. We do the same thing with 18, divided by 0.75. And we come up with a final answer of n is equal to 24. So Latoya's softball team played 18 games. And if we take the fraction 18 over 24 and divide, we would get 0.75 or 75% as well. So your assignment for today is page 115, number 1, 3, 5, 7, and 9.